Hi, thank you all for coming. And it's especially nice to see some non-MFA photo people who have joined us today. For those of you who don't know me, my name is Adam Bell, and I'm the academic advisor and faculty member in the MFA photo department. And we are very excited to have Lev Manovich here to give a talk. And as a bit of history, I'm especially excited because I remember when I was a student not too long ago, or actually maybe a little bit long ago, back starting in my first year in 2001, I remember buying and reading Lev Manovich's famous book, The Language of New Media, and being amazed by it and thinking it was this brilliant book. So it's really great to have him here now. For those of you who don't know a little bit about Lev, I'm going to do a sort of abbreviated bio, which I've taken from his website, which I'll just go through quickly here. Lev Manovich is an artist, computer animator, designer, and programmer, as well as an author of numerous books, including his most recent, which is Software Takes Command, Soft Cinema, Navigating the Database, and The Language of New Media. He is currently a professor at the Graduate Center of CUNY and the director of the Software Studies Initiative that works on the analysis and visualization of big cultural data. In 2013, he appeared on the list of 25 people shaping the future of design, and in 2004, he was included in the list of the 50 most interesting people building the future. In addition to being a former Guggenheim Fellow, he has also received grants from the Andrew Mellon Foundation, the National Science Foundation, and the National Endowment for the Arts. For those of you who want a closer look at some of his work, I would encourage you to check out his website, which I'm sure he's going to show today, which he's worked on, called On Broadway, and also to check out the Public Eye photography show at the New York Public Library, which is up now, and I think, does it run until next March? Until January, okay. Which is a fabulous show, and I highly encourage you to check it out. So it is a great honor to have Lev here, and this will be a fantastic lecture.
Well, thank you, Adam, and thank you guys so much for organizing this. And we hope it maybe not going to be my last engagement. We're talking maybe about doing some workshop with some students. So hopefully you still like me after this first date. Now, I know you got some students who were actually required to come here, so please don't hate me after this, okay? And if you hate me, I'll buy you beer. So today I'll be talking and actually showing you a range of projects we have done in our lab, which trying to look at massive image collections using techniques of data visualization and also computer vision. And I'm specifically going to focus on the projects where we look at photography via Instagram. But before I show these projects, I want to make a kind of more general statement. So, I think last year, President Obama, right, said that to be literate in our society, you have to know how to program. I mean, now I'm sure you have other, people you maybe admire more or respect more. But when the president of United States says everybody has to program, I was very happy to hear that, because those of us who have been involved in digital art, and I've been involved for about 30 years, of course, we're dreaming about the moment where people will actually say, hey, it's not enough for me to know how to press a button on my Leica or make a PowerPoint. I should also know something about the code, because the code is to a modern society is what I would say electric engine, the trains, and other kind of technological forces were to industrial society, right? Everything runs on code. Well, we know that. Even President Obama knows that, right? So that's not a big news. But what you guys may not have realized is that, in fact, if you think about visual culture, right, in the history of media, 19th century, we got photography, we got Fox, we got television invented in 1870, and then, of course, all these things become really big in the 20th century. Radio, again, television, video, internet, and so on. Right? But I think that maybe 5 to 10 years ago, in fact, our society has entered a new stage, or let's say our media culture have entered a new stage, and amazingly, nobody has written about it yet, as far as I know. So I don't have a name for it, but maybe we can call it something like computational media or even cultural analytics. So basically, a significant number, right, of cultural interfaces, right, that the companies put up for us to interact with culture depend on computational analysis of massive amounts of media, right? So while I'll be using some of the same techniques as a way to do a kind of art history or archaeology of the present, right, I think you want to be curious and I think you want to learn about these techniques just because, you know, if you want to be a literate photographer, right, or a literate artist in 2015, you should know how mass visual culture works. You should know how culture industry works. And I'm telling you, not all of it, but to a significant extent, it works on, not just on code, right? Not just on, you know, MySQL, you know, Python, and so on. It works on the particular techniques of analyzing massive amounts of media. I mean, think about Google search. I mean, how does Google search works? Well, Google sends robots. You know, we go online, we travel from one web page to another web page. There's maybe about 14 to 15 billion web pages today, according to best estimates. It extracts all the content, right, from every web page. Right. It analyzes all this content, right? Whatever it is, you know, breaks it down. If it's images, it's also images, puts it in database indexes, and then when you search for something, it will return pages which you think are most relevant, or in the case of images or video, it will be images or video. So search, which is now our interface to information, as opposed to, let's say, library catalog, depends on massive processing of cultural content, such as web pages and other stuff online. Right? Recommendations, right? So if I go to Amazon and Netflix, you know, they're going to recommend me some movies to see, or some books to buy, or, you know, baby diapers, or maybe some super expensive lens for my camera, or whatever, right? But how does Amazon knows what I like? Well, it looks at what I'm looking at, it looks at what I'm buying, it compares me to the same buying histories of billions of our user sessions, and then again does calculation. So in this case, the calculations are done not on the actual media, such as photograph or web pages, but the calculations are done on my cultural preferences, right, my buying history. We go to maybe one of the more popular kind of newer news website, such as Mashable.com. So I was talking to a guy who is very chief data scientist, right? And he says that, so we build an algorithm, right, which basically recommends to journalists every morning what we should write about, you know, based on processing, again, billions of numbers, you know, what people looked at before, what people looked at last year. But I think what's even more amazingly, like when he told this, I was just totally shocked. So we have an algorithm which is in real time adjusts the position of articles on the page. So it analyzes the data, right, of people kind of visiting its website, you know, using some old data, and it basically uses this to automatically adjust position of images. Okay, so, right, I mean, like you look at this, it looks very innocent, but it's a kind of, right, it's like an alien from a new era, except the new era we're already living in. So those of you who are obsessing about becoming a famous photographer because you're going to take this one amazing photograph, I'm not against it, right? But you have to be really genius, right? You know, because so many great people took so many great photographs. But if you want to get into algorithms and code, and in fact processing of visual information, and thinking about massive image collections, and then combine it with artistic ideas, intellectual ideas, maybe UI for photography, you can do some really bad project and become famous, because this is completely new, right? So at this point, the industry is like decades away, right? While we're kind of clicking and looking at single images, the industry is processing billions of images, billions of data points to create these crafted experiences for us. So how can we take these techniques and actually use them more humanistically to do some interesting things, to do art, and maybe to also understand patterns in history of photography. Right. So I'm going to start with a recent project we have done. It was an invitation from MoMA, right, Museum of Modern Art. We've been working for a few years on a big project, which is now exhibited, called Modern Photographs from Thomas Walter Collection. It is an amazing exhibition, so go see it. If you can afford $25, but you can get artist membership, actually, and go lots of time for free. And as a part of this exhibit, you know, we commissioned people to write essays. So we invited my lab to look at the photographs of this collection and see if we can use computational and visualization techniques, you know, to maybe say something interesting. Well, so I sent one of my students, you know, he was a research fellow last summer 2013, he was really nice to them, and after a while they gave him the whole digitized photo collection of MoMA. So I don't know if it's all, or we think it's all, nobody knows, but 21,000 photographs. Okay? So how does 21 photographs from MoMA looks like? Show you. So we this is a 70-page or PowerPoint. We presented to them our findings, and eventually we asked them to reduce it to 10 pages. So you can look at the essay online, but I'm just showing all the stuff. It didn't make it to print, and we also had a signed agreement that we're not allowed to show it to anybody or publish it. But here it is. But you guys don't tell them, right? Anyway, so just one more second, please. Okay, here we go. Yeah, this is a big one. Okay, so this is one of many visualizations we have done. So what it is, it's with 21,000 photographs from MoMA collection, simply organized by year. And of course it reveals something we may suspect that MoMA collection, right, because for decades MoMA was the first museum to collect photography, right? So MoMA was very important in making photography part of our art and our history. But you may expect that maybe very, very strong in a between war avant-garde, but it's really, really strong, right? So basically this is, in the 19th century we have something, and then between 1920 and 1940, look at how huge their collection. And remember, it's very little from the 50s, and remember, there's a little bit more maybe, in the 60s and 70s, and then, there's almost nothing after that, right? So now you can see why museums don't publish visualization on their websites, because then everybody know how particular their collections are. But the reason I'm showing it is the first thing. Yes, of course you can represent the same information as a bar plot, but then it looks very abstract, right? So in our lab we developed simple software. It's open source software. We've been giving it away for free since 2010. Where you can actually make these visualizations yourself. So the idea is to create visualizations of the image collection, which would not just show you patterns in a collection using points, bars, rectangles, and so on, right? All this kind of data visualization porn, sometimes people call it, but in fact, make visualization out of actual images in the collection, right? So if I start zooming in, as long as the computer can keep up with me, eventually I'm going to actually see, the actual images because visualizations made from them. And then, of course, these bars now become very, very meaningful, right? Because, of course, what you see is that these images, which really can dominate, right, MoMA collection, it's not just any particular images, but the images of very particular modernist avant-garde photography, right? Very abstract, black and white, some kind of fragmented body parts, right? Lots of defamiliarization. Maybe this concept of Australian defamiliarization, and so on and so forth, right? So in fact, the collection is really dominated by a very particular type of photography. So it in no way represents the history of photography as it actually happened, right? It doesn't represent vernacular photography, right? So in this case, visualization can show it. Now, as you just saw, right? Once you start creating these visualizations, where you actually want to show massive image collections on one screen, things like laptops or these awful devices, right? They call mobile phones. They're basically awful, right? Because they prevent you from thinking, right? So the last 15 years was a kind of waste, in a certain sense, in terms of artistic digital imagination, because everybody trying to make these little apps, right? And this is like Atari, right, of 1970. And if I only would stare at this awful device, I would never think about, let's visualize whole MoMA collection. So I was very lucky, until I came to New York, where you wouldn't even find a space to put this wall. Well, maybe you guys can find a space. I was a professor of art, digital art for 20 years. And I got involved with a research institute called California Institute for Telecommunication and Information, where people are basically devising the information structures for the next generation. So we're devising next generation internet, next generation computing, where CPU will be here, and then the graphics card will be in Taiwan, and the screen will be in Mexico, right? So the computer is distributed. The internet, which is not using normal cables, it's using optical fibers, so it's super fast, and also designing next generation displays, right? Because we're saying correctly, well, if the world is connected, right? If we're all talking to each other, if we're all uploading, rating, liking Instagram photos, right? We're producing massive amounts of cultural content and cultural communication. So this device is totally idiotic, right? You're basically looking at the world for a little keyhole, right? I mean, yes, it's amazing in one ways. As a communication device, it's amazing. As a device to think about art, right? It's like, okay. I wouldn't break it, but I just won't. But maybe like if you invite me to lecture again, like before my contract, I'll just kind of break it. Okay, so these devices are much better, right? So this is the kind of visualization walls I was lucky to work with at the University of California, San Diego. This is one of many we built. So this particular wall consists from dozens of kind of large 46 monitors. So it's and then there is a bunch of PCs of high-end graphics card, kind of things you use to play video games. Behind it, so it's a little visual supercomputer. So I can load a big image collection, and you'll see the second sorted, and basically do exploration, right? So the kind of things, maybe photographers or photo editors in magazines like Life or Vogue, right? Or whatever, we're doing for decades, right? Where you put your photographs on the wall, and you decide, like which photo shoot is going to go where, what's editorial, what you're going to select. So, this is in fact a very, I think, common practice in the kind of photojournalism community. But what if you can do it with a computer, and what if you can actually do it with billions of images? So let me show you a little video, which we shot when we kind of spent a few months and developed a little software for this wall. It's kind of old, it's 2009, but it communicates the idea.
We're here at the Hyperspace Wall at Cal IT2, and we've loaded an image set of the works of painter Mark Rothko. Using software developed by the Software Studies Initiative and the Hyperspace Wall team, we're going to be exploring this set of paintings using cultural analytic techniques, turning the paintings into sets of data that can be graphed and turning those graphs into collections of paintings. First, let's take these images and let's move them over onto part of the wall's surface and then load some graphs on the other part of the surface. These graphs all run over the years of Rothko's career from left to right, but their heights are indicated by different features of the images themselves: texture, brightness, number of shapes, saturation, and we can use them to explore trends in this painter's life and work. So let's organize this tile set that we have by one of these dimensions of data. We can sort through different axes, looking at something as simple as just the sequence of files, which we can view at different sizes, all the way down to a series of dots. And we can size all the way up to high-resolution textural images. I'm going to turn the size on this down slightly, and then I'm going to add a transparency effect. You can actually see the original dot data in the midst of the color cloud, and by mousing over any individual painting, you can pick it out of the space of color trends over the course of Rothko's career. I'm going to turn the transparency feature off now, and then size these images back down to a normal set. Now we can see the individual paintings no longer overlapping. Let's look at another axis. We can cycle through all of these various axes and perhaps arrive at one that has a particular shape or has an image like this one right here. We can see that if we size that particular image up that's standing out from the graph and choose to look at it, we can see that this one particular painting is quite unusual in Rothko's career for one or another low-level statistical reasons. Now, this doesn't mean that we have to do all of art history or all of visual analytics based on low-level mathematical statistics. But it does mean that the graph becomes an occasion to pick out an image and say, oh, this breaks the pattern, or this is typical of the pattern. Why? What's so particular about this image? The important thing about this software is that it allows me to explore transparent views. It allows me to look impressionistically at the way the data explodes into more complexity at one side of the screen. and focuses off on the other. Let's go back to a tile view of looking at all of these images again.
So you got the idea. So basically we wanted to build the tools which would allow us to explore patterns in image and video collections of any size. And we thought, well, why don't we use computers to extract various characteristics from images, brightness, color, RGB parameters, texture, and then create another software tool which would allow us to basically sort this collection in real time by any of these characteristics. Okay, so I'll show you next, some projects we've done more recently, where we use these techniques. But before that, I kind of want to also demo for you, let's say, one of the recently emerged companies. There's now a few companies which actually offer, computer vision for the masses. And when people normally think about computer vision, digital image analysis, or machine vision, all this term kind of means the same thing. You say, Lev, so what are you guys doing? You're probably guys doing like face recognition, or maybe you automatically can recognize the subject in photographs. Well, in fact, we're not really doing it that much. Because the computer vision has developed since late 50s. In fact, the basic techniques were really developed in the 1960s, but it only became possible to process millions of images very quickly in the last 5-10 years. And if you have an image, right, and you want to measure, let's say, average brightness value, you can do it for every image, right? You just look at every pixel and divide the number by number of pixels. So when you take a photo, right, and you guys all have like these really soft-up cameras, right, and the camera shows a histogram, right? So the computer is basically doing the same analysis. It analyzes pixel values in the image. It then shows you a graph, a kind of visualization, right, of pixel values. So you can do this. You can use these techniques for every image. But if you want to ask computer to do more, what's called high-level analysis, try to recognize faces, maybe age in the photo, gender. That still works pretty okay. But if you want to ask a computer to maybe recognize the type of scene, the type of object represented, it's getting better, but it's not that amazing. So I will show you also one of the projects where we're using, for example, computer vision analysis from the same company, and it worked really well. And I'm thinking this year that maybe we can try to experiment with scene analysis, but it's very, very uneven, right? So if you want to find, let's say, passenger cars in the photo, maybe it works with 90% accuracy. If you want to find red flags, maybe it'll be 30%. But the field is developing, so perhaps in a few years, it would work quite well. And obviously, things like face recognition I build anywhere, right? By building all the photo cameras, from iPhone, right, up to the most expensive, Nikon. I mean, right, things like Facebook also recognize faces, so face recognition works pretty well, right? But let's actually see how, what kind of things the computer can extract. So by the way, if you want to use this company, I mean, it's just one of them. I mean, I'm not like paid with them, but I'm showing it to you because it's the same company we used to do one of our projects, Selfie City. So most of them give you basically ability to do some free processing, right, without paying if a small number of images. And oh my God, it just changed. I'm sorry. Like I honestly, I looked at this a few days ago, and we had like I guess when the company just starting up, we had a free count, so we were able to process 5,000 images for free. But now it's already $99. But okay, but $99 is still not a lot. So you can basically get the count for a month, analyze 40,000 images, and get out. Or for $100, for $1,000, you can analyze 1 million images, which is probably like all the photographs in all the museums in the world, right? So if you want to find out what really happened with photography, it will only cost you $1,000. Of course, you also have to have some good ideas and know what to do. So how does it work? Right. So this is what we have. Okay. So the computer basically looks at the face, right? Analyzes pixel values, and eventually gives you lots of information. Right. First of all, it says I'm confident there is a face. Value is 1. But what's interesting, right, when the computer gives you these answers, and that's also very important to understand about contemporary kind of computer-based knowledge, what I call software epistemology, the knowledge is probabilistic, right? It's not certain. The computer gives you percentages. It says, well, I think the rate is white, I'm pretty sure, but I'm actually 97% sure. The age, I think, is 25, right? The smile, I'm pretty sure it's 1, right? So some values it says I'm sure, some values it gives you probabilistic, right, value. And the thing about computer vision, if you want to use it like in your projects, it works very well if you give it this kind of perfect images, right? So here's a perfect face and a perfect background, there's nothing else. But if I start giving it more real-life images, like what you had on Instagram, right, it may not work maybe as well. So here are just some collection of just random Instagram images, actually, right, from our project. So we can just kind of try it out and see if it's going to work or not. Okay, so let's just see. Okay, so that actually seems like it's okay. So for example, it found two faces, but I missed this girl. Sorry. Okay. 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 So what about this guy, right? So okay. I think it's Slavoj Žižek actually. Okay. So obviously he's not recognizable, right? Okay, so even a very simple thing, right, which computer scientists have been working on for 70 years now, 60 years, face recognition kind of works, but not perfectly, right? Which of course has huge implications for privacy. You know how America has 1 million people on this kind of dangerous list, right? So if you go to an airport, maybe some of you, particularly if you have a foreign citizenship, you're being pulled out, there are children on this list. Obviously most of these people are there because of errors, right? And now you can see why. Now you can see the dangers of our society switching to computers. Now, if you want to use computer to do, for example, understand the content of a scene, yeah, if you give it this perfect image of a beach, it says, I think it's a beach, 46% accuracy, but it says, I also think maybe it's a mountain, 7%, right? Okay, so well, so how do you kind of use this, right? And again, if you start giving it some random images, we can just try. I mean, I'm not even sure what happens, right? So let's just give it some random Instagram image. Well, it's pretty good. It is a food, 4.46%. But also thinks maybe it's a restaurant, 1%, right? So this, so because I'm kind of saying it because there are some people who have been looking, seeing my work and work our lab and saying, Lev, aren't you kind of this formalist? Why you always organizing images by these formal features like color, bright, and so on? I said, well, I would love to do content, but it's sort of hard, right? It's sort of hard. Even the state-of-the-art software, you can see, kind of makes mistakes very easily. Okay, well now that I kind of gave you this, I kind of condensed, like a whole course into 10 minutes, and introduce you to maybe very, very basics of, what a computer can do, how a computer analyzes images, and how we can use visualization then to use the results of this analysis. I will show you some projects. Okay. So first, we spent a few years applying these techniques to rather small image collections, and actually very kind of famous type of images because we wanted to make sure these techniques are going to work. So here's just one example. So according to the best estimates, the Impressionists, which is artists which participate in the Impressionist exhibitions, right, in Paris in the 1870s and 1880s, so about I think 13 people, 15 people, they painted about 13,000 pastels and paintings. Obviously, there's not a single book where you can see it, right? So when you guys think about Impressionism, you think of Van Gogh flowers, or maybe you think of Monet, so water views, but you think of something, right? Maybe like this, very light, kind of happy, right? Instagrammy, right? Kind of pre-Instagram, right? Kind of vulgar, right? I mean, it's a really vulgar art, right? That's why it's so popular, right? Look at this, Anyway, okay. So what we've done is, my students, we spent a couple of classes, and we collected, we tried to collect all the images of Impressionist paintings we could find online. So we didn't find all 13,000, but we did find about 6,000, which is 50%. And then we used computer vision to automatically measure, right, which is to convert various properties of images into numbers, right? So in this case, there's maybe 200 numbers, which the computer extracts from an image. So the computer looks at, for example, amounts of red, green, and blue. The computer looks at line orientation. The computer looks at textures, right? And when you put it all in the algorithm, and we're using, if you're interested, these details, the algorithm we're using is from 1901. It's fundamental algorithm of data science from 1901. It just shows you how much things progressed or not. It's called principal component analysis. And it's basically a workhorse of contemporary data science, right? So the idea is that we have a collection of objects. In this case, we have a collection of images. And we want to organize these images in such a way that the images which are similar are next to each other, and the images which are dissimilar are far away from each other, right? And we want to do this as perfectly as possible. Well, in reality, right, there is no perfect solution to this problem because images can be similar in so many different ways. So it kind of depends on parameters you use. But this is, one of many possible outputs of such an algorithm. And you can see it's making lots of mistakes, right? So here's a blue image next to brown images. But if you zoom out, it actually works pretty well, right? And what you realize is that, in fact, what people think of as Impressionism, right, which are these pretty kind of maybe slightly vulgar images, is maybe about 30 to 40% of what Impressionists produced. So this is what we started to find out when we applied these techniques to various canonical sets of artistic images. If you think that a particular artist like Van Gogh or particular, let's say, artistic movement like Impressionism is about something, it's about X, it turns out that in fact it's only a small part of what people produced, but these images are disregarded, right? They're not written by historians, they're not in museums, mostly, right? They're not in blockbuster exhibitions. They kind of deleted from art history, right? So art history, so this is the whole thing. And you can see, surprisingly, right, Impressionists have produced lots and lots of these very dark images, which in fact are very similar to what other people in the 19th century were doing, right? So this is more typical, it's the art of the 19th century, and this is the outlier called Impressionism. And by organizing images by visual familiarity, you kind of get a good sense of proportion between, these images which are more famous and these images which are not famous, right? So that's the real picture of Impressionism. Yeah, sure. So lots of my portraits. I mean, it's probably images we painted maybe in the early part of our career, right? Before we kind of discovered, our brand. Yeah, maybe also Manet, right? But it's just quite interesting how many of them are here, right? So this is another example of what the Impressionists have produced, right? And they produced a lot of it. Okay, so that's one example. So now you can say, Lev, that's kind of fun, but can we maybe animate it to see how these things develop over time? Okay, so we created this animation. So this is the same thing, but in this case we're just using one artist. So we digitized all his images from a catalog Raisonné, which he created between 1905 and 1917, right? Just before he developed his kind of canonical grand style, right? And we said, how can we use these computer techniques to imagine an artistic development, right? The artist is developing, he's searching for things, eventually he's going to arrive at his unique style, his unique visual language. But what is the space of the search, right? Is it something similar to biological evolution? How if you believe in biological evolution, and apparently 70% of Americans believe in both Darwinian evolution, and 70% of Americans believe also in God. So I'm not quite sure how it works together, right? Our life is full of contradictions. If you look at what the side people had, it's like terrifying. So what we've done is we've done the same thing, right? We use this technique, which is again the most basic technique of data science, principal component analysis. We extracted about 60 different features, which is numerical characteristics of images, things like texture, number of shapes, colors. And then we organize all these images again automatically. The algorithm organizes these images, like all the images he painted between 1904, 1905 and 1970, right? 12 years, about 144 paintings. And then we simply animated this, right? So what you can see is that kind of going back from this final figure, the images are going to pop up in the same year as they painted, and then the year is going to appear in the upper left corner, and what you're going to see is a possible visualization, right? A suggested view of, in fact, how artist is developing and looking for his or her unique, let's say, visual language in the space of infinite possibilities, because every possible image you can paint, photograph, imagine will be somewhere in this square, right? So let's see how it looks. Again, I want to point out this is not science, this is more like art, this is suggestive. So the idea is not to come up with like a new canonical interpretation of what happened to modern art, the idea is to basically enlarge your ideas and give us more ways to think about both present, our own photographic production, and also cultural history. Okay? So I'm going to run this. You get the kind of shape. So as you see, the year appears in the upper left corner. Okay. So very interesting. So let's do like a kind of close analysis, right? A kind of like a close reading of this process. Okay. So in the beginning, I think he's basically stuck. You know how guys want to become artists, right? You went to some high school, you have a slightly decapitated art teacher thought you had talent, Now you end up, now your parents are paying for art. I don't mean SVA, I mean some like art school X, right? Art school X, right? And now you're like, okay, why do all my photographs look like really bad Richard Prince, or like Richard Avalon, right? Okay. Well, Mondrian was, he was no genius either, right? He was basically a bad schoolboy, So he's making those paintings. And the thing is, if you look at a museum, you're also going to find that very similar. But I think visualizing in a more structured way, where in fact, a measure of visual distance, a measure of visual difference between the images is translated into distance, I think it makes it more precise, right? So you can see, in fact, the images are very similar, right? They kind of is somewhat abstracted landscape. In fact, he's already kind of abstract, right? Which I didn't know that. So he was a good boy. He was a kind of boy genius, but we didn't know that. And the colors are really similar, right? So this was in the old days, early 20th century, when artists maybe would take 20, 30 years to mature. Now, of course, the situation is different, right? You make one good photo, next day you have a show, in Greenpoint, and even the next day thrown out, and you basically dragged out in the hospital. So, but so it takes some time, right? Because probably if you do it, probably you'll never get beyond this, right? So don't you want to become Mondrian? Anyway. So okay, so he's stuck, right? 1905, 1906, 1907. I was like, oh my God, the guy's in his 40s already. What's happening? So when is he going to break through, right? Now you can see things become a little bit more interesting, right? The space becomes a little bit bigger, but it's still all in one place. And finally, oh my God, 1907. Oh my God, boom! Okay, so here's his breakthrough painting. But you know what happens? You know how in life you can't change overnight. So yesterday you were basically like a successful lawyer, and today you're going to enroll as an undergraduate to art school X and say I'm going to become a photographer, but you're still secretly taking photographs of like law books or something, right? Or you had a relationship, it's over, and when you guys kind of do these hookups, and when you both feel bad in the morning, right? So I think artistic development is the same, right? I find that it's very difficult for me to wake up tomorrow and start writing about something very different, or start making photographs in a very different style. So the moment he makes this new painting, he starts going back. So for a while he oscillates between what he was doing earlier and the new Mondrian. You see? He's kind of going back and forth. But as things develop, right, he's more brave, he's exploring a larger and larger part of the space of possibilities, and eventually, right, we didn't finish, we didn't get to his most canonical images, but this is where we got to 1917. Now, of course, right, this is not precise. In fact, this is suggestive. You can also visualize the same information in millions of different ways. But I think it's interesting, right, because what you find out is that, right, as he develops, his new images are further and further away from where he started, right? So the difference in, let's say, visual language, and we use the visual parameters, increases, right? So by the time we finished, he's like somewhere here, 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 very far from where he started. But I think it's also interesting to see that as he develops, he explores a larger set of possibilities. So let's say somewhere by 1912, he makes images which are here, all the way here, and also all the way here, right? Very, very different. So he's not developing along a single line to go from point A to point B, but in fact, he's kind of covering this larger set of possibilities, and then a few years later, he's going to arrive at his kind of canonical brand style, which will, for better or for worse, will make him famous. So I think it's very suggestive, right? Very interesting way to look at the, let's say, artistic, stylistic development, and of course you can apply it not only to history of photography, individual photographers, you can also apply it to individual artworks. Okay, so now that I showed you some examples, right, of what you can do, let me show you sort of our more recent projects, where in fact you can apply these techniques, or even more simple techniques, to try to understand patterns in the kind of vernacular photography, right, in social media, visual social media data. Specifically, we focused on Instagram. So I'll show you about 5 projects very briefly, which we did in the course of a year and a half. Now I'm trying to recover and write a book about it, because it was very fast. So for our first project, right, we basically said we're just going to take a first look. We don't know what's on Instagram, but we know it's not just selfies and kitties. It's probably a whole visual universe, which is probably as rich as MoMA, maybe more. So I think our goal was both to understand larger patterns, what these photographs look like, but also try to combat, right, the popular opinion with social media is just trivial, with Instagram is just, for nobodies, But you guys know, of course, it's not true, right? But people in the street don't know it. So we downloaded. It's basically me and one graduate student. So the whole project was done with laptops. So we downloaded 2.3 million Instagram photos from 13 global cities, and then we set out to kind of visualize these photos in different ways, right? So most simple way, right? Again, in this case, we're not using any kind of complex, even basic techniques from data science. So we simply took all the photos, right, which we shared in the center of a particular city or a data set, and we simply visualized them, right? Again, in a very kind of obvious way. I mean, we're not obviously, we didn't invent this way. The photos are basically organized left to right, right? Left to right, top to bottom. Sorry, left to right. Left to right. Basically goes like this actually, in order of upload. So this is 53,000 photos from Tokyo, which we're taking over a few consecutive days, right? So but you can also zoom in. So we built this interactive website. So you can zoom in, move around, and see the details. And what's interesting is that you get this kind of sense of what I would call kind of collective, right? Montage, collective, city film, right? You have contributions of probably 25,000 users, right? Everybody is taking images of what they like, so people don't make some agreement. Okay, let's all go photograph, ramen, right? Or let's all go photograph, this. It's basically spontaneous expression of our free will. But of course, we're not so free, right? We follow particular patterns, right? We get up in the morning, have coffee, I mean, check out Google Analytics, That's what I do. Maybe you're checking Facebook Analytics or whatever, right? When you go to school, etc., etc. So what I find kind of interesting here, right, is that every day and every night, I mean, maybe it's a bit hard to see here, when we just actually download this image. So all visualizations were done as a principle. You can download them at the highest resolution, 50,000 pixels, make prints, we don't charge you. It's all open source, including our software. So I just downloaded this image so we can actually look at this at a larger scale. So as you can see, there are these kind of nice patterns, right? Day and night, but it's not perfect because people also sharing lots of light photographs during the night. But what's interesting, every day and every night is a bit different length, right? Because the length of the day and night is proportional to how many photographs people uploaded in a particular sitting of the day. So one day is longer, one day is shorter. So you don't get the perfect bar chart. In fact, you get this kind of subjective, objective, and kind of social city unconscious being kind of visualized spontaneously out of all these photographs. So that's one thing we've done. And then the second thing we've done is we made these 50,000 image samples from a number of cities, and we organized them, again, using these very basic visual characteristics which the computer can extract from images. It's not hard to guess what we are. So in this case, the average brightness, right, is controls how far the image is from the center, so very light and very dark. And then the average hue, right? Yeah, there's such a thing as average hue, average color, which if you kind of add all the colors together, it kind of works. Controls the angle of the image, right? So from 0 to 360, and here you can see very kind of broad strokes, right, which part of a color spectrum has been kind of filled in, right? And what parts of the color spectrum is missing. And I think there's one thing which is missing very, very, very clearly, because this image is done with cities. So what is one color you don't see here? Green, right? So not much green here, right? Not much green here. Okay, this is Tokyo. Okay. Yeah, a little bit different, actually more red. Right? In fact, more red, maybe more night activity, all this neon, not much green, right? Now, so here comes the interesting question, right? So here, let's say with 3 visualizations. Right? And we show you patterns which are, on the one hand, very similar. On the other hand, there's a big difference, right? There's some difference. I mean, here is a whole gap, so particular colors are missing. Okay. It's a Bangkok, right? So these kind of images are missing. In fact, you don't have as much red. There's a little bit of green. And here you have something else. Now, of course, we can use statistics and statistical analysis and do statistical tests, right? If you want to kind of, let's say, scientifically make a statement, they were these image collections are in fact similar or different according to the colors. But I'm not sure how a statistical test actually will be meaningful to anybody in the room, including me, because we also have common sense. Right? So here's a question, right? Do all these visualizations tell us that in fact the combination of modern cities, which are becoming more similar, plus Instagram, which is the same app, right? The same interface given to everybody. You have these filters which appear in the same order. Everybody takes the same pictures, which are square pictures, plus maybe some kind of visual influences. So do all these factors, right, which combine globalization, urbanization, software interfaces, do we lead to certain kind of monoculture, right, where people are taking the same images, or are these differences significant, right? Are these differences significant enough to say, in fact, people are actually taking different photographs in different cities? Yes, you can do statistical tests, but what do we care, right? And actually, I think there is not a clear answer, right? I think the answer really depends on our interpretation, right? So again, the point of this visualization, not necessarily to give you a clear answer, but in fact to give you maybe some more detailed ideas, but also to open the conversation. So this was the first thing we've done, and of course, it's a very, very rough approach, right? We didn't really differentiate with images in terms of subject matter with different users. We only have a look at colors. So then in the next project, at Selfie City, we said now we're going to focus on particular type of images. So in this case, we said we're going to basically now try to compare apples and apples as opposed to just compare everything. So I had a larger team this time, all right? So it's about 8 people, including some leading visualization designers, data scientists, art history, PhD candidates from CUNY Graduate Center where I teach, makes undergraduate students, so a combination of data scientists, art historians, even people like me who don't know really anything precisely, just in between, right, all the fields. So we decided, to do a project on what my team thought was an interesting idea, like selfies. So we decided to do it in August of 2013, and I've been really trying very hard to convince my team not to do it. Guys, this is so banal. Like none of my academics friends are going to, respect me. And we said, Lev, we know what we're doing. Just sign the check. So they convinced me to do it, and of course we got like thousands of newspaper articles about it. The people I spent months and months answering interviewers, questions. Now of course I understand what the awful thing popular media is. You can notice a single person ask us, well, how you guys collected the data? Did you actually check your results? Whatever I said, because I have PhD after my name, we just tried. So it's very interesting about popular media. So here we basically try to look at this, try to compare selfie photographs from 6 different cities, and again to kind of maybe talk about the same question, which is, are we going to find more similarity? Right? Are people kind of taking selfies in the same way, regardless of, let's say, gender, ethnicity, age, or are we going to find enough cultural difference, right? So to what extent Instagram, which I think leads to perhaps certain, certain uniformity, right? For one thing, everybody takes the same picture, and then you're using a mobile phone, which also limits to your photographic kind of, right? Photographic mise-en-scène techniques. Are we going to find more uniformity, or are we going to actually find that despite this uniformity may be imposed by the software and hardware interface, there's still enough of a cultural difference? So we have done a variety of different visualizations. So here's, for example, we kind of show you again how computer can look at images. So here's a selection of images from different cities, which are sorted, very, very kind of just in one way by face orientation. And then we kind of also show you like how does the actually computer look at images, so you can crop them. Okay. And then you can also rotate it, right? So you can go from the normal view to computer view, just to of course remind people that we have bad things like NSA and in fact these techniques are also used for lots of evil purposes. In fact, right, face recognition, as I showed you, very dangerous because it doesn't work very well. So then what we've done is we created this kind of graphs, which basically looks like a normal histograms. We compared the cities by a couple of characteristics, right? So in this case, it's a smile distribution, right? So amount of smile by gender by city, right? But instead of making like a typical graphs, we can make these graphs once again from images, right? So again, the idea was not to reduce individual differences into a summary, into the aggregate, right? Which is how statistics and graphs are typically used, but the idea is to create some kind of displays, graphical representations, which on the one hand allow you to see patterns, but still remind you that these patterns emerge out of individuals, right? So you can move around, you can see kind of all the individual histogram images, right? And then you can zoom out and see the patterns, right? And here like little kind of, so little findings we put, but you have to click on them, right? So of course, you see that Bangkok people smile much more, right? So in Sao Paulo, you can also see there are more female than male selfies, right? Because female is in the top area and males is the bottom area. In Moscow, we don't really smile, I mean, now we smile even less, right, after what happened, but we really don't smile in 2013, right? So then we kind of wanted to be able, right? We said, well, if we want to leave a project on the level of visualizations, this is a little bit abstract. This is maybe more interesting to visualization designers or to visual artists. I mean, journalists are not going to write about it. So we wanted to create a larger window so that normal journalists who are not interested in visual culture can write about these projects. More people can visit it, and then maybe more people can get into, and look at these graphs. So what we have done is we have done this very conventional, right, on purpose, like pure internet research type of findings. And again, on purpose, use very familiar graph. Right? So we say, oh, we only found 4% of selfies. There are more female than male. And of course, that's what everybody wrote about, because this is kind of statistics people expect, right? But again, for us, it was a kind of device to have a bigger window to catch kind of more visitors, and then hopefully some visitors would go in and actually look at what the project was really about, which is the interactive interface we built, where again, the experiment with combining representation of patterns, right, via these kind of graphs, and in fact, the representation of the actual media, which gives rise to this pattern, right? So here's a whole kind of collection. So we collected, it took like months and months, because we wanted to collect data under the same condition. So eventually we got 3,200 selfies, so 640 selfies from every city. So you can browse them. And then here you can basically select these filters, and you can filter them, right, by different characteristics. And of course, you can now use the same interface for any image collection. For example, potentially you can put all the kind of photos from MoMA into the same thing, right? So we can, for example, select all the female selfies, right, versus male selfies. And now, of course, we get a precise number. Okay. We can also say, let me select all the, for example, selfies from New York. Okay. And now, out of these New York selfies, we're going to select people who are pretty old, like after 30, right? Well, meaning Instagram old, right? So it's about, not that bad. So here's all old people, but not that many, right? Now, what's interesting is that, see, this is a kind of histogram, right? Which shows the overall distribution of ages in these photos. How do we get the ages? We put this in mechanical Turk, we ask people to guess the age, and we also use the same kind of face recognition software. The age was very similar, so except software always judges people to be younger, because maybe people want to sell it. So what's interesting, if I basically select Bangkok, you see how we have a second graph which overlaps? So now we can see right away that the selfies from Bangkok tend to be younger than overall population, whereas the selfies from New York tend to be older. Right, so this is a kind of combination of computer and humans, and always our stuff is computer, right? So we use this face recognition software which I showed you. At one point it was still free, and we extracted 20 different parameters. So for example, you can say, well, what about all the kind of faces which are extremely tilting to the right? Okay. So, oh, they seem to be females. How interesting, right? And most of them seem to be in Sao Paulo, right? So you can see how it works. And then you can nest these filters, right? You can say, now I'm going to select all the people who are like really, really happy. Okay. And then like really old happy people. Okay. Okay. So again, it's obviously not only interface, but this is the direction, right, in which I wanted to go since set up a lab, right? To be able to create interactive interfaces which will allow us to explore, right? For people who don't have technical skills, any collection of images or video of any size, right? And be able to actually see the individual images, yet at the same time see patterns. Okay? I know I'm aware of time, but I should probably finish like 2 minutes, 5 minutes. Yeah, I will show, right? Okay, so very briefly, I'll just show you two more things. Okay, so this is a project I've done also last year myself mostly. So here we wanted to look at even a more local collection of Instagram images, even more filtering. So basically, there was a revolution in Ukraine, Kiev, right? Ukraine is a country which was part of former Soviet Union. For those of you who don't know, the word was in the news a lot. So it was a revolution about a year ago, where people occupied the main square, and was lots of confrontation with police, and then eventually, after a few days, the government ran away, and then the new government took place, and then immediately, a few days later, of course, Putin said, no, it's not good. We're going to attack Crimea. So we've done this project about this. We basically downloaded all Instagram photos, right, from a kind of square situated around the main kind of place where all the protests were going on. And I said, what can we tell about the city from its photographs, right? So as opposed to simply saying, how do people who are organizing a political revolt, right, or revolution are using social media, just how is everybody using social media in the city during this event? To what extent this event even registers? So we've done lots of things, we analyze text, we look at combination of images and text, right, etc., but I want to highlight a couple of things, right? One is, right, so this is again the same visualizations I've done earlier in our photoreels project. So the revolution kind of starts here, really goes on the way here, and by this time we have new government. And what's interesting, right, you can't even find it, right? So the exceptional, right, is kind of drawn, right, it kind of disappears in the series everyday Instagram photos. So a project turned out to be not really about revolution, a project turned out to be about interplay between everyday, right, because, maybe there was a revolution happening right now on Wall Street. Maybe there was like a military putsch, but we don't even know, right? We're still taking our selfies. And then the exceptional. We use different techniques to do it. We also commissioned a bunch of different essays from different people to write about it. So the project becomes a kind of platform where quantitative analysis, visualization coexist with kind of critical essays by different people, both students and also kind of faculty in different universities. But what I also want to show you is another method we try to kind of understand what's inside these images, which is the computer clustering. Right? So here we can again analyzing images in terms of very low-level characteristics, color and so on, and feeding them in the computer and asking the computer to automatically divide all these 13,000 images, which we shared in Kyiv during 1 week, into groups of similar images. So the computer divided all images into 50 groups. Some are just complete garbage, but some actually work very well, right? So here's a group we found, which have images which happen to be mostly city scenes with particular composition, right? Here, in fact, the images we also found, which are lots of kind of collages and text over image. And here is one of many variations of selfie species, right? A particular selfie species. But the computer doesn't know it's a selfie. The computer just knows that there's something dark in the middle and something light around it. It's interesting that you can use these methods where the computer doesn't know anything about image content, but simply analyzing images by similarity in terms of colors or pixel values or texture, you can actually find these kind of clusters of similar images. And what you realize is that something relatively small, right, which is a collection of like 13,000 images, and the images which we shared during the exceptional event, right? But if you just look at this, you organize images, one by one in order we shared, it looks like a complete, right, kind of crazy, super modernist, kind of montage plus, right? So here's, the revolution, here's the events, here's somebody's eye, here's somebody's selfie, here's the food, here's products, right? And it's kind of impossible to see what the patterns, right? I mean, how prevalent are selfies, how prevalent are, the images of revolts, right? But by using kind of computer analysis, we can actually find this island, right, of similarity. And what it also means is that if we deal with dozens or hundreds of photographs, you don't need computers, right? You can just use your human eyes. If you want to make sense of photographs, let's say created by millions and billions of people, maybe find most interesting photographs on Instagram, or even just get a sense of like what happened in photography history, you kind of have to use computer methods, because once you go into tens of thousands or millions of photographs, the eye can't really understand the patterns anymore. So finally, very briefly, I'll show you our latest project, which Adam already mentioned. So it's currently installed in New York Public Library as installation, but we also try to make most of the stuff available online. So basically what it is that here we kind of zoomed in even more, right? So we kind of go from comparing 13 cities to when looking at the selfies in 6 cities to when looking at a big part of one city. And here we're actually looking at single street. So we wanted to create a very kind of data-dense representation of a single street in New York, which is Broadway, right? So we tried to collect various data which would fall within the kind of Broadway corridor. So we have here 22 million taxi rides along Broadway in 2013. All the publicly shared Instagram images along Broadway from 2013 for 6 months, so that's 660,000. Twitter images, Foursquare, like 8 million Foursquare check-ins, but also census data from US Census, right? So what we're doing now is writing papers where in fact we're comparing patterns in social media, right, Instagram and so on, to the characteristics of these neighborhoods in terms of income, ethnicity, and so on. And we even be able to actually put the installation, well, we even be able to kind of turn installation to kind of app, although it doesn't work as well because you need to have very fast computer, very fast connection. I can see this is not, but probably if you go to Starbucks, it will work better. Anyway, so we kind of made a reference to a project which inspired us. So basically, I'm going to finish by going back to history of photography or history of modern art. So this is a famous project by Californian artist Edward Ruscha from 1966, where he created this very long photo book, where he kind of mounted himself and a camera on a car and was driving along Sunset Boulevard in Los Angeles and just taking photographs of like every X meters and then put it in a book. And I thought, this is great, but this uses the state-of-the-art technology from 1966. It makes a certain statement about, let's say, banality or similarity of its buildings. But in fact, besides these similar buildings, people are very different. People are very diverse, and where acts, behaviors are very diverse, where images are very diverse. So of course, what we're interested is, in fact, explore more with diversity and variability in such patterns in New York. So again, we work with a team, with a bunch of people. We went through lots of different sketches, trying to figure out how we can represent all this data. And eventually I said, okay guys, we're going to make a project which will not have a single normal graph, and it also will allow you to represent the city without maps. Everybody uses maps. Fuck it, we're not going to use maps, right? And then we become famous. That's how you do it, right? Everybody becomes a photographer and takes photographs. You say, I'm becoming a famous photographer, I'll never take a single photograph. I have no idea how to do it, but that's a good plan, I think, right? Anyway, so here we're trying to visualize, the data. You can see like household income, taxi drop-offs, taxi pickups, and then eventually we created this kind of a, like set of layers, which you just saw, right, where you can animate, where you can kind of go through installation, you can zoom in, you can pinch out, pinch back, and you can kind of navigate through kind of the city building by building, or you can zoom out to see the patterns. So that was another experiment, another attempt to figure out how to allow kind of seamless navigation of large image collections. I mean, we couldn't put all the Instagram images in installation, it's only 40,000, but it's still a lot. But also somehow make you think about the invisible patterns, right? The invisible patterns of, how many Twitter images people tweet in a particular location. That's where household income. So basically, I think to try to work on what I think is perhaps one of the most essential cultural and artistic problems of our time, which is how to navigate between our familiar world of visible appearances, which we can capture in beautiful photographs, and the new world of big and dangerous data. Thank you so much. So in most of our projects, right, in fact, we don't use this kind of high-level computer analysis, precisely because it's actually maybe too imprecise. So in fact, right, that's why I would say until recently, most of our projects, we just visualize things based on very simple things, which in fact are reliable, right? Things like color characteristics, texture characteristics, and so on. Now, when we did this project, right, the Selfies project, where in fact we have used, computer vision, we can look at the results, and we actually find that in many cases the results were actually very good, and in some cases were awful. we decided to, we kind of talked about, we decided to leave it in as a way to actually remind people, but in fact, these techniques are now becoming ubiquitous, as I tried to mention in the beginning, and these techniques actually make errors. So to me, this is not maybe something I want to hide, but in fact, it's something I want to actually make visible and discuss, right? But I also want to say, I think that the way our society uses these computer techniques, right, is ultimately this analysis is reduced to a number. Is there a face in the photo? How many faces? Does this face belong to the terrorist database? In our case, as you can see, we are kind of actually not really showing you we can show you average statistics, but that's about it. But mostly we show you the whole image collections, and then you yourself can see patterns, right? So the idea is again not to use computers and give us correct or incorrect answer, which will be a number, but in fact show you all the visual information in such a way that you can see patterns and you can also see variability and kind of diversity of these images. I also didn't mention that we also use, we kind of hacked into Google Street View, so what we're also seeing is a kind of Google Street View of the whole. If you kind of imagine if you take a car all throughout Broadway, so you can see how after a while you get much more sky, right? So yeah, we can measure it, we can give you a number, but I think what's interesting, but of course it's not perfect, right? Reality is not perfect. So I think our whole enterprise is basically trying to recover from modernity, trying to uncover from 19th, 20th century world, which was about statistics, which was about reducing very complex things like society to small numbers, right? Where Marx reduces society to two classes. Well, it doesn't work like this. Augmented probability, let's see. We haven't used it, but let's just see what we have here. Oh yeah, I see beauty point 9987. The thing is, that's the thing, right? We haven't used this. We only used sort of some more let's say objective parameters, right? For example, like face orientation, right? Role, etc., etc. We have no idea, right, how the algorithm works. And of course, we're not going to let you know because when some other company will copy it, right? And that's I think another kind of danger of the systems because they're kind of black boxes. So we give you results, right? So let's say there's a system which may give you a number about how beautiful or how personable you are, and then let's say based on this number you'll be hired or not, and people hired but have no idea actually how where the number came from, right? But as I said, it's actually only time we use a system about which we don't know how it works because we have tried to use open source code, it will work as well. But normally, we write our own code and basically everything we do, we know how it works, right? But in this case, we use something where actually we don't know how it works.